Okay, we're on to exponential functions. Now, exponential functions, what we have here is a base, and it's the actual exponent that's the variable, as opposed to something down here, which is what we're used to, x to the power 5. So you're graphing 2 to the power 5, 3 to the power 5, 4 to the power 5, okay? Here, something like this, 2 to the power 1, 2 to the power 2, 2 to the power 3. It's the exponent that's the variable, okay? Now, little other rules. We cannot have the base as a negative number. Think about this. If I raise negative 1 to the power half, that's square rooting. Well, I can't square root negative numbers. And if you think about this, negative 1 squared is a positive answer, negative 1 cubed is a negative answer, so that'll be flip-flopping either side of the x-axis. Also, we can't have 1 as the base, because 1 to any power is just 1. That's not going to change, okay? So you've got to think of it like this. Anything from 0 to 1, but I can't have 0, I can't have 1, and then anything beyond, okay? So here's some examples. 2 to the power x, half to the power x, 3.57 to the power x, all examples of exponential functions, okay? Let's have a look at some graphs. Right, nice simple one, 2 to the power x. So if I do a table, 2 to the power 0 is 1, okay? Now, this point here, I'm actually going to put a big underline over this, because anything to the power 0 is 1. So 0, 1, this point right here, will be on every exponential graph. Okay, doesn't matter, it's half to the power 0, 8.6 to the power 0. The answer will still be 1. So that point's always there, except if you start to do transformations. Okay, so look at this. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. Remember, it's the exponent that's the variable. So it starts to look like this. So every exponential graph pretty much has this shape, because look at it when you actually do some negative numbers. Okay, so remember, negative's not the base, negative is the exponent. 2 to the negative 1. 2 to the negative 1 is the same as 1 over 2 to the positive 1. Remember your negative exponent rules, which is 1/2. Okay, so down here. 2 to the negative 2 is 1 over 2 to the positive 2, which is 1/4. Down here. And so on. Okay, there's 1/8. Now, can you see, this is going to get closer and closer to the x-axis. The x-axis here is one of those horizontal asymptotes. Okay, in fact, if I look down here, you can have a quick read of that. Okay, so this gets closer and closer, but doesn't touch. But that is the general shape of these exponential graphs. Okay, well, at least when it's something bigger than 1 as the base. Okay, right. Let's have a look at another one. Okay, so in fact, I'm just going to bring that. I'm going to just raise that a little. So I'm going to show you something. Okay, so here we've got a fraction as the base. Now, what they've done here actually is change it to the base of a whole number. Okay, instead of a fraction, we've got something bigger than 1. And if you see the rules, 1 over 2 is the same as 2 to the power of negative 1. So these two are exactly the same. But you don't have to do this if you don't want to. You can put this in your calculator. Half to the power 0 is 1. Half to the power 2. Half to the power 3. You can put it in your calculator, and this is what it should look like. So I sent it. I'll just do this. Watch. Okay, look at this. Flip, flip, back and forth. So 2 to the power x, half to the power x. 2 to the power x, half to the power x. Okay? But what we can actually do here is we can also see it as a transformation. Okay? I'll deal with transformations later. But 2 to the power x, which this one is, if I reflect it through the y-axis, that's 2 to the negative x. That is y-axis reflection. We'll look at that later. But this is the graph of a half to the power x. We can write it as 2 to the negative x. Okay? Right, so let's have a look at some more. Right, here's where some transformations are. So remember, what 2 to the x? So based on the fact that we're starting with 2 to the x, okay, which is this one here. Okay, we're right here. Let's bring this up. There's 2 to the x. 2 to the x minus 2 means we are going to move it to, now, okay, 2 to the that direction. Okay, to that direction. This is like, remember these? X squared. Then I did x minus 2 squared. That was a transformation 2 to the right. Okay, just based on the old x squared graphs. Okay, so we've moved it 2 to the right, and look, can you see this? Whereas this is where I said it always crosses. Okay, right here, the y-axis. I've moved it 1, 2. It's moved 2 to the right. Kind of hard to see with left and right transformations. Now this one, this is just a classic. Remember this? If I had an x squared graph, and then I wrote -4 at the end. I just moved it down 4. Well, again, this one has been moved down 4. So instead of the x-axis being that horizontal asymptote, I've got -4 as the horizontal asymptote. So again, when it crossed the y-axis at 1, down 1, 2, 3, 4, can you see it's crossing the y-axis at -3? Okay. Let's have a look at one more. This one here. Okay, over the page. Right, here it is. Now then, they've again kind of shifted it slightly. You can think of this as, remember, the half to the x graph. That's what 0.5 is. In other words, it looks like this one. Okay, but of course that is 2 to the -x, so we can think of it as y-axis translation, reflection across the y-axis. But I was just thinking to myself, that is what half to the x looks like. Okay, so I'm going to do it slightly differently. If that's what half to the x looks like, look, a minus in front means reflected over the x-axis. So if I take this and reflect it over the x-axis, I'll have something that looks like that, won't I? I'll just go this down like that, okay? So this now will be at -1 on the y-axis instead of +1. So reflected through the x-axis. Then a +5 means move it up 5. Okay, so there it is. So if I reflect the original one through the x-axis and move it up 5, 1, 2, 3, 4, 5, yes, it's going to cross at 4. And look, that y equals 5 is going to be the horizontal asymptote. Okay, so I did it slightly different to what they did. But if you change this to look like this, then what it is it's the regular exponential graph. -x there, which means I flip it through the y-axis. Negative in front, flip it through the y-axis, so x-axis, sorry, then move it up 5. And that's what that should look like, okay? So there you go.